So P1 is a point riding on a black ellipse, and what I'm drawing in the center is the envelope of the bisector to two segments. These segments are defined here for simplicity as follows. I'm going to place a first point Q1 on one focus of the ellipse and another point Q2 somewhere in the interior of the ellipse, okay? So you can see here that I'm computing the bisector Q1 PQ2, showing the bisector as this red dotted line. Here's the local or instantaneous point of tangency to the envelope, and this four cusp curve is the envelope. You can see that the four cusps are located conveniently. Here's the first cusp, the second cusp on Q1, Q2, and the other two are located in the line that is perpendicular to Q1, Q2 at the midpoint. All right, now if I place Q2 on the other focus, focus of the ellipse, like so, the curve that you get, the envelope that you get, is a familiar one. This is known as the evolute of the ellipse, and it's called an astroidal or astroid curve. Okay, why is it the evolute? Because we know that the bisector, or sorry, the local normal, the evolute is the envelope of the normals of a curve, right? But the normal of an ellipse coincides with the bisector to the segments to the two foci. This is known as, I believe, Graves' theorem. Okay, so you get this evolute. But the subject of this video is the following. I asked myself the question, what is the locus of points of Q2, right? What is the locus of Q2? And it's this green curve for which the evolute, or sorry, the envelope being drawn here, the sort of distorted evolute, has the same area as the evolute. So here's the evolute. And a point on this green curve gives me this other distorted evolute, but the area of this distorted shape is the same as the area of the evolute. So let me attach Q2 to this green curve, like so. And let's animate Q2 as well. So, you know, the animation of P is immaterial here. Let's stop this animation of the P point. And I just want to animate now Q2 on this iso area curve, if you will. Okay, now all the envelopes that you're seeing here have the same area as the standard ellipse evolute. And in fact, when Q2 is on the right focus, you get the evolute itself. Now, numerically, and this could be a close approximation, okay, this isocurve is a circular arc. Okay, there could be some very close approximation here that I'm missing, but numerically, this thing looks like a circular arc. In fact, the isocurves of area of Q2, if you don't impose it to pass through the other focus, are all circular arcs that extend over to the left here of this curve. Okay, but I thought this was a pretty interesting phenomenon, and that's all I have. I'll see you on the next video.